This is chapter 11. This is part 3. So for this problem, we're going to have to use several different conversions, and I'll remind you of them as we go along. All right, the prescriber writes an order for 1,000 milliliters with 10 units of Pitocin. Your patient must receive 3, this is milliunits, of this drug per minute. Calculate the flow rate in microdrops per minute. Okay, so one of the things you might remember, or maybe not, microdrops is right here. 60 mcGTT is equal to 1 milliliter. So we're going to need that conversion. I'll go ahead and write it down here. 60 microdrops is the same thing as 1 milliliter. Okay, so we need that. We need the definition of milliunits. 1 unit is equal to 1,000 milliunits, which is that lowercase mu. Okay. All right. So let's start off with what we need. We're supposed to get 3 milliunits per minute. We're supposed to end up with microdrops per minute. We already have minutes, so that's really nice. Okay. So now I'm just going to start trying to get from milliunits to microdrops. Okay. Let's go ahead and go to units. There are 1,000 milliunits in 1 unit. Okay. So the milliunits cancel out, and you end up with 3 over 1,000 units per minute. I'm not going to worry about simplifying that until the end because things will cancel out. Okay, so we don't want units. We've used this conversion. This one doesn't have units, but we have not used this information yet. Okay, so this is the strength of what's going to be given to the patient. There are 10 units in 1,000 milliliters. Okay, so I'm trying to get rid of units, so I'm going to put 10 units in the bottom and 1,000 milliliters in the top. Now the units are going to cancel, and if you look here, I have 1,000 here and 1,000 here, so that cancels out as well. So right now I have 3 milliliters per 10 minutes. Okay. Now the last thing I need to use is that there are 60 microdrops in 1 milliliter. So I have 3 milliliters in 10 minutes. And I'm trying to get rid of milliliters. For 1 milliliter, there are 60 microdrops. Okay, so the milliliters cancel out. If I divide this by 10, I get a 1. Divide this by 10, I get a 6. Multiply straight across, I'll have 18 over 1, so just 18 microdrops per minute. And that will be your answer. Okay, so let's look at number 6. Calculate the number of units of regular insulin a patient is receiving per hour if the order is 500 milliliters with 300 units of regular insulin and it is infusing at the rate of 12.5 milliliters per hour via the pump. Okay, so we start off with the order is 500 milliliters with 300 units. Okay, and it is infusing at the rate of 12.5 milliliters per hour. And I want to end up with units per hour. Okay, well, I want to end up with units on the top. Here's where I have units, and this is the relationship between, it's going to be the strength of what's given, the dosage rate. So I have 300 units over 500 milliliters. Okay, we know it is infusing at this rate, so milliliters are going to cancel out if I put 12.5 here. Okay, the milliliters cancel out. If I divide each of these by 100, I end up with 3 over 5. And I want to end up with units per hour, which I've got. So all I need to do is, if I multiply straight across, I'll end up with 3 times 12.5 to get 37.5. And I still have a 5 here in the bottom, and I'm in units per hour. Okay, now divide this by 5 to find that there are 7.5 units in an hour. Okay? Okay, so we need to go to 11.7. Okay. An IV bag contains 1,000 milliliters with 500 milligrams of a drug. It is infusing at 12 drops per minute. The drop factor is 10 drops per milliliter. Find the dosage rate in milligrams per minute. Okay, so I'm going to start off with what we are giving. We are giving 500 milligrams. And there are out of 1,000 milliliters. So this is the strength of the drug over the volume given. Okay, I want to end up with milligrams, which I've got, per minute. So I'm going to have to convert somehow milliliters into minutes. So let's look at what we have. We've used this information. It is infusing at the rate of 12 drops per minute. I don't have drops here yet, so I don't want to deal with this one yet. The drop factor is 10 drops per milliliter. Here's the milliliters that I want to get rid of. So I'm going to put 1 milliliter in the top, and then 10 drops in the bottom. So if we simplify this, if I divide this by 100, I lose 2 of those zeros. I'm just making my life a little bit easier. The milliliters cancel out, and this is not fully simplified, but I will have 5 milligrams per, that's 10 times 10, so 100 drops. So I'm getting there. So I have milligrams and drops. I want minutes. Now what I have not used yet is right here. They're given 12 drops in a minute. I'm trying to get rid of drops, so I'm going to multiply by 12 drops per 1 minute. Okay, the drops cancel. 5 times 12 is 60. I have 60 milligrams in 100 minutes. Okay, and then divide both of those by 10, and then 6 divided by 10, well, that's 0.6 milligrams per minute. Okay, now if the recommended dose is 0.5 milligrams per minute to 2.5 milligrams per minute, is this infusion in the safe dose range? Well, these are milligrams per minute, which we have right here. 0.6 is between 0.5 and 2.5, so it is safe. Okay. Example 8. The order is for 40,000 units of heparin in 1,000 milliliters at a rate of 30 milliliters an hour. Find this rate in units per day, and then decide if it's in the safe dose range. Okay, so I have 40,000 units in 1,000 milliliters. Okay. All right, so, and it's supposed to be infused, I'm looking for units per day, okay? This is in milliliters per hour. I can use this. I need to get rid of milliliters anyway. So 30 milliliters in 1 hour. Okay. If I divide this by 1,000, I end up with a 1. If I divide this by 1,000, I end up with a 40. Milliliters cancel. 40 times 30 would be 1,200 units in 1 hour. Okay, now we are asked to go into units per day. We've got units per hour. There are 24 hours in 1 day. Now, so hours are going to cancel out. I need to multiply 12,000 times 24. When I do that, I get 28,800 units per day. All right, and then asked if it's in the safe dose range. Safe is between 20,000 and 40,000. 28.8 is definitely between that, so it is safe as well.